Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have n to the power of 12 minus 1 equals to 0, and we will solve this problem for the values of n. So here we find all the roots of n. So the very first thing we are going to do is here first we write this equation as n to the power of 12, and we will write it as n to the power of 6 and its whole square minus 1 square equals to 0. So here we need to use the nice square identity, and you know that it is equals to n to the power of 6 minus 1 into n to the power of 6 plus 1, and this whole equals to 0. So here we have two cases. The first case is we write n to the power of 6 minus 1 equals to 0, and the second case is we write n to the power of 6 plus 1 equals to 0. So in the next step we will solve these two cases here. So I can name this as equation number 1 and this as equation number 2. So now first we will focus on equation number 1, and now equation number 1 implies that here we write n to the power of 6 minus 1 as n cubed and its whole squared, minus we write this one as 1 cubed equals to 0. So in the next step we will open this is 1 square equals to 0. So we open this square identity and we write it as n cubed minus 1 into n cubed plus 1, and this whole equals to 0. So here again we have two cases. The first is we write n cubed minus 1 equals to 0, and the other case is we write n cubed plus 1 equals to 0. So in this case, in both of these cases we will use the nice cubic formula. So you know that about cubic formula. So the formula of this term equals to n minus 1 times of n squared plus n plus 1 equals to 0. And similarly we will use the cubic formula here, and you get n plus 1 into n squared minus n and plus 1 equals to 0. So these are the two cases, and now we will solve both of these cases. So here again you write n minus 1 equals to 0, and we write n squared plus n plus 1 equals to 0. So here you obtain the value of n equals to 1. So this is the first root of the given equation. And now we move toward this quadratic equation. So in this nice quadratic equation I can use here the quadratic formula. So you see that we have a equals to 1, b equals to 1, and c equals to 1. So our quadratic formula will be n equals to minus b plus minus square root of b squared minus 4 times of ac over 2 times of a. And now we put all the values of a, b and c here, and you get the values of n. So we have minus 1 plus minus 1 minus 4 square root over 2. So here you obtain the other two roots of the given equation are minus 1 plus minus minus 3 square root over 2. So when you open this square root, then you will get here minus 1 plus minus square root of 3 iota over 2. So these are the other two roots of the given equation. And now we move towards our second case. So this is our second case of here, and now we can write it as, here we write n plus 1 equals to 0 and n squared minus n plus 1 equals to 0. So here you get the value of n equals to minus 1. So this is the first root, these are the two second root, and this is the third root of the given equation. And in order to find the other roots, we will solve this nice quadratic equation. So here we use the quadratic formula, and you have a equals to 1, b equals to minus 1, and c equals to 1. And I can write here this quadratic formula, and you can just put all the values of a, b and c in this formula, and you will get here the value of n equals to here you have minus b, and we put minus value here, so minus time of minus equals to plus 1, and plus minus square root of b square. So b is minus 1 and minus 1 square is 1, minus 4 times of a and c is 1, so it will becomes 4 over 2. So when you can simplify these terms, then you will get here the values of n equals to 1 plus minus 1 minus 4 equals to minus 3 square root over 2. So similarly, uh, when you open this square root, then you will get here 1 plus minus square root of 3 iota over 2. So these are the other two roots of the given equation. So here we can find the 6 roots of the given equation, because here we will solve this sixth order equation. And now we move towards our second case. So in second case, so here first I can write our equation number 2. So our equation number 2 implies that n to the power of 6 plus 1 equals to 0. So now we will rearrange this equation as n squared and its whole cubed, plus we write this one as 1 cubed and it is whole equals to 0. So now we can open or use the nice square identity, and you will see here the cubic formula of a cube plus b cube equals to n squared plus 1 into n squared and its whole squared, and minus n squared and plus 1 equals to 0. So here we have again two cases. The first is we write n squared plus 1 equals to 0, and the other case is we write n squared and its whole squared minus n squared plus 1 equals to 0. So in this case you will get n square equals to minus 1, and the value of n equals to minus 1 square root, and you will get here n equals to plus minus iota. So these are the other two roots of the given equation. So now we move towards this fourth order equation, so that you can see here this is quadratic in n square variable. So now we can use here the nice quadratic formula, so that here we have the value of a equals to 1, value of b is minus 1, and c is 1. So because it is quadratic in n square, so we can write here n square, and you have minus b plus minus b squared minus 4 times of ac square root over 2 times of a. So now we put the values of a, b and c here, then you get 1 plus minus b square equals to 1, and minus 4 times of a is 1 and c is 1, and this whole square root over 2. So that you will get here 1 plus minus minus 3 square root over 2, and you will get here 1 plus minus square root of 3 iota over 2. So this is the value of n square, and in order to find the value of n, we will just take square root on both of the sides, and you will get here n equals to plus minus square root of 1 plus minus square root of 3 iota over 2. So these are the other two roots or four roots. This equation gives the fourth root of the given equation. So these are the four roots and these are the two roots. So these are the total 12 roots of the given equation, and this is our final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.